Alright, so in this video, we're going to talk about chemical bonding. Now, there's a reason behind chemical bonding. Chemical bonding just involves you just study how atoms bond together, molecules bond together, and so on and so forth. You understand? Now, there's a reason for bonding, and the octet rule is going to help us explain why atoms bond together. Octet rule. Now, first things first, yeah. And when we look at the periodic table, okay, we have hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, and so on and so forth. You understand? Now, according to the atomic number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We can observe that these ones here are called noble gases, you understand? And the reason they are called that is because they are called inert gases because they hardly react, you understand? And the reason why they hardly react is because of their complete octet or duplet structure. I will explain. Now, if you are to draw this in a shell-like manner, for hydrogen, is going to have the first shell. Now, the first shell accommodates 2 electrons, so hydrogen is just going to be 1. So that is lacking one electron in the first shell. We go to helium. Helium is going to have 2 electrons, and this is complete for the first shell. You understand? So helium has a complete duplet structure. Because it has 2 complete electrons in the first shell. The maximum number of electrons the first shell can contain is 2. 2 electrons. You understand? So it has a complete duplet structure. Now we go over to lithium. Lithium has 3. So the first shell is going to contain 2. 1, 2. Then the other shell. Now the other shell can contain 8. You understand? So it's going to have 1 outside in the second shell. But now if you observe, it needs 7 more electrons. So it's not stable. You understand? But if you go down to neon, neon has 2 in the first shell, and it has, after 2 minus 10 minus 2 gives 8. It still has 8 more. So 1, 2, 3, 4, 5, 6, 7, 8. Now you can see that neon has complete octet structure. Octet means it has 8 complete electrons in the outermost shell, in the valence shell. You understand? It has 8 valence electrons. Is that okay? So the reason why there is chemical bonding is because all the other elements from here down are trying to attain the kind of structure that the noble gases have. Understand? That's why they have bonding. Take an instance. You can say, let's say sodium. Sodium is trying to react with chlorine. Okay, sodium is going to be here. Sodium is going to be here, and chlorine is going to be around here. Now, you can see that, take an example of sodium trying to react with chlorine. We're going to write that down. It's just to attain the octet structure. So let's take an example using this sodium and chlorine. So we have sodium. Sodium has the atomic number of 11. We have chlorine. Chlorine has the atomic number of 17. So if you are to draw, instead of drawing that, you know that the first shell contains 2 electrons. The next shell contains 8. The third shell, now we have 2 plus 8, right? That's 10. So what is remaining is just going to be 1 electron outside. Understand? Now we go over to chlorine. Chlorine has 2 in the first shell, 8 in the second shell, and 8 plus 2, this gives 10, right? So in the third shell, you have 7. Now, in order to have a complete structure, because the tail shell will still be 8. And that will have a complete octet structure. Chlorine will need one more, you understand? It will need one to make it 8. Sodium will easily lose one, you understand, to have 2 and 8. So sodium wants to what's going to happen is that sodium is going to lose one of this to chlorine. Understand? And whenever an atom loses electron, it becomes positively charged. So we're going to have sodium being positively charged because it just lost one electron. You understand? Now chlorine has gained. Okay, let's write out the. Now since sodium has lost one electron, it's going to have a configuration of 2 and 8. Understand? Which gives it stability, just like neon. So now we go to chlorine. Chlorine has gained one electron, and whenever an atom gains an electron, it becomes negatively charged. So it's going to be 2, 8, 8. You understand? So this is a kind of bonding. So when they bond, that's why you're going to have sodium chloride at the end of the day, because the charges will cancel out. Positive cancel out negative. You're going to have sodium chloride, your table salt. So this is the reason why sodium and chlorine bond together, because they both give each other a complete octet structure. You understand? Although this is a particular type of bonding, we're going to discuss other types, but this is just a basic idea of what's going on. Understand? This is the reason why we have bonding. So there are things that will help us explain bonding. Okay, let's talk about the types of bonding. Let's talk about types of bonding. Let's talk about the types of bonding. Now, the first type of bonding is the first type of bonding. Okay, when we talk about bonding, yeah, we're going to talk about bonding in terms of two contexts. The first context is when we talk about the intramolecular bonding, and the second type is going to be the intermolecular bonding. So when we talk about the intramolecular bonding, we're talking about bonding that happens within molecule. You understand? Within a molecule. Let's say we have a molecule of let's say we have water molecule H2O. Understand? The bonding that occurs between hydrogen and oxygen inside this is the intramolecular bonding. But if we have, let's say, two molecules of water, H2O, in two places, and they were bonded together, the kind of bonding that occurs is the between two molecules. You understand? It doesn't necessarily mean of the same. Doesn't necessarily mean the bonding must be between the same molecule. Can be between a molecule and another. But I just want you to get the idea that intra is what occurs between hydrogen and oxygen to form water molecule, but inter is what happens between water and water molecule, or water and another molecule. So that's what we're going to study. Now we go over to let's start with the first one. Let's start with the intramolecular bonding. So for the intra, we're going to have okay, the first one we're going to consider is the ionic or electrovalent bond. The next one we're going to consider is the covalent bond. And lastly, the one we're going to consider is the metallic bond. So we're going to study these three types of bond under intramolecular bonding. Understand? So let's go straight to it. Now, We're going to start with the ionic or electrovalence bond or bonding. So the ionic or electrovalent bond. Now, it involves the transfer of electrons. Involves transfer of electrons from one atoms to another. For one atom to another. Now, it involves transfer of electron from one atom to another. The first atom that transfers is usually a metal. Most times is a metal to a non-metal. So when we talk about the transfer of electron from a metal to a non-metal, we are talking about the ionic or electrovalent bond. Now, the example I gave you earlier on about sodium and chlorine is a perfect example of, it's a very, very good example of the ionic or electrovalent bonding. So now let's look at another example similar to the first. Let's look at magnesium and oxygen. We have magnesium, we have oxygen. And magnesium has an atomic number of 12. Oxygen has an atomic number of 8. So for magnesium, the first shell is going to have 2. The second shell is going to have 8. 2 plus 8 gives 10. The third shell is going to have 2. Magnesium is a metal. Oxygen is a non-metal. Now for oxygen, on the other hand, the first shell is going to have 2. The second shell is going to have 6. So now if you observe, magnesium will easily give out 2 than gain 6 to complete the structure. So it just needs to lose this 2. Oxygen, on the other hand, needs to gain 2 to gain a complete structure. So what's going to happen is that magnesium is going to lose 2. Magnesium is going to lose 2 to oxygen. And remember what we said, that whenever an element loses electron, it becomes positively charged. So magnesium is going to have a charge of 2 plus because it lost 2 electrons, you understand? And we're going to have a configuration of 2 and 8. So this is octet. This is a complete, it has gained stability. Same thing goes for oxygen. When oxygen gains 2 electrons, it becomes negatively charged. So you also have to indicate the number of electrons it gained. So this is going to be 2, 6. You see that the bond between the both of them has given them complete octet structures. Understand? So we're going to have this. That's an example of the ionic or electrovalent bond. Another example is that of sodium. So you can pause the video. Sodium and fluorine. Sodium has same thing. We talked about sodium, which is 11. Talked about, okay, fluorine is 9. So this is going to have 2 and 7. Okay, 2, 8. This is going to have 2, 8 and 1. Fluorine is going to have 2 and 7. You see that this just needs to transfer to this. So you have a stable atom. So you're going to have sodium plus because it lost 1 electron, and fluorine minus. So when you combine this, you have sodium fluoride. Do you understand? So this is just the basic idea of the electrovalent or the ionic bond. So the next thing we're going to talk about are some of the characteristics of these ionic compounds. When they are formed, what are their characteristics due to the type of bonding that occurs between them? Perfect example is your table salt, which is sodium chloride. We talked about it earlier on. Sodium chloride. So what are the characteristics of this compound that is formed and others that are like it? So the first characteristics is so we're talking about the characteristics of ionic compounds. Characteristics of ionic compounds. So the first characteristics is that they exist as crystalline solids at room temperature. Crystalline solids at room temperature. So they are crystalline in nature first, and they are solids at room temperature. Now we go to the second characteristics. They do not conduct electricity in their solid state. So obviously, we look at the table salt. The table salt is solid at room temperature. You understand? But on its own, like that, at the solid state, the table salt will not conduct electricity. The only way that your table salt can conduct electricity is when you pour it into water or you make a solution of it. You understand? That is the only way it will be able to conduct electricity. So ionic compounds do not conduct electricity in their solid state, but in their molten state or in a solution, they conduct electricity. And the reason is because when they are in a molten state, in a solution, the ions, when they're in a solid state, the ions are not what causes something to conduct electricity is the ability of the ions to move. The ions conduct the electricity, you understand? So in a solid state, now the ions are tightly packed and they don't have the freedom of moving. But when you dissolve it in water, they can now move a little bit freely. So this is why they conduct electricity, you understand? So another characteristic of the ionic compound is that they have high melting and boiling point. Obviously, as I said earlier on, because they are crystalline in nature and they are solids at room temperature, they are they are tightly packed, and you need a high amount of energy to break down this stuff. You understand? That's why they have high melting and boiling points. Now, obviously, when you have sodium positive charge and chlorine negative charge, they are going to come together to form sodium chloride. Now, there is a very high and strong electrostatic force between them, obviously, because of the signs. So they're going to be tightly packed together. So for you to break the electrostatic attraction between the two of them, you need a very, very high amount of energy. That's why they have high melting and boiling point. Now, go to the fourth characteristics. They are soluble in polar solvents. They are soluble in polar solvents. An example of a polar solvent. An example of a polar solvent is water. Another example of a polar solvent is methanol. We go to the fifth characteristic. The fifth characteristics is that since they are soluble in polar solvents, they are insoluble. They are insoluble in non-polar solvents. An example of non-polar solvent is benzene and toluene. Maybe in the next video we'll talk about polar solvents and non-polar solvents. So this is basically the major things you need to know about electrovalent or ionic bonds. So the second type of bond we'll talk about is this, which is the covalent bond. Let's talk about the covalent bond. Now, for we to talk about the covalent bond, there's something that we need to do first. Something that will help us understand when we want to draw diagrams, and that thing is called the Lewis structure. Now, the Lewis structure is just used to show how atoms are attached to each other in a molecule. Don't worry, we're going to see. You just have to deal with let's say you have hydrogen now. The atomic number of hydrogen is 1. I know that in the first shell you just have 1, so you're going to have hydrogen like this. Then you indicate with just a dot to show the 1 valence electron. Understand? We have oxygen. Oxygen has atomic number of 8. We know the first shell contains 2. The second shell will have 6. So if you are to draw the lowest structure, it's just oxygen. Then you show the six. We have one, two, three, four, five, six. So this is just the lowest structure. Sometimes they don't use dots. Sometimes it can be X. So you can have one, two, three, four, five, six. So this is basically what we're going to be using to understand the covalent bonds properly. Now, what are covalent bonds? Now, in the first one we talked about an ionic bonds. We talked about transfer of electrons from one atom to another. But this time around, there's no transfer. This time around, there's something called sharing. This time around, there's sharing of electrons. So when you hear the word sharing of electrons, you're talking about covalent. Now, from the word co, you share equally. You understand? So we're going to okay. It just involves sharing of electrons equally between two atoms. So we're going to take an example as hydrogen. So we have hydrogen molecule. Now the hydrogen molecule, there's a difference between hydrogen atom and hydrogen molecule. Hydrogen molecule is this way, H2. Understand? So it comprises of two hydrogens being bonded together to give the hydrogen molecule. Now let's see, we know that hydrogen has an atomic number of 1. Hydrogen also has an atomic number of 1. So let's say the first hydrogen has one valence electron. Let's show it this way. And the second hydrogen has valence electron X. It's the same thing, just use different symbols. So when they bond together, you're going to have sharing of electrons. So the first hydrogen is going to bring that its own. The second hydrogen is going to bring its own, and you're going to have something like this. So obviously now this hydrogen has two complete, it has a duplet structure. Remember, the first shell now has two electrons, similar with this, because they're both sharing each other's electron. So this is a complete, this is a stable atom. You understand? That's how they will tell you hydrogen is diatomic, because it cannot, if it occurs just like this, it is unstable. So it has to bond with another atom to be stable. Another example is chlorine. Chlorine also is diatomic. When you do the structure and everything, you see it. Chlorine has an atomic number of 17. So the first shell is going to be 2, the second shell is going to be 8, the third shell is going to be 7. So we're going to have 1, 2, 3, 4, 5, 6, and let's give the last, okay, 7, right? Now the second chlorine is going to have 1, 2, 3, 4, 5, 6, 7. So when they bond together, they're going to be chlorine, chlorine. You're going to have 1, 2, 3, 4, 5, 6, 7. And then you're going to have also 1, 2, 3, 4, 5, 6, 7. You can see that they're sharing one atom each. Understand? So this is just covalent bonding. Then let's check another example that doesn't have to deal with diatomic atoms. Let's take an instance. Let's say we have ammonia, NH3. Now we have nitrogen. Nitrogen has an atomic number of 7. Nitrogen has an atomic number of 7. And we have three hydrogens, three molecules of hydrogen. So hydrogen has an atomic number of 1. So the first shell is going to have 2. Then 7 minus 5 gives 7 minus 2 gives 5. So the second shell we have 5. So nitrogen we have something like this. We have 1, 2, 3, let's say 4 and 5. Understand? Now hydrogen on the other hand, hydrogen has just 1. So let's put the 1 this way. So now for this thing to work, we need 3 molecules of hydrogen. So we're going to have nitrogen. We're going to have nitrogen here with its 1, 2, 3, 4, 5, 5. So we have 1, 2, and we have 3. We can have 4, and we can have 5. Now please mind you, the placement doesn't matter for now, unless we're talking about the shape. Understand? But for now, just look at it this way. So we are going to have 1 hydrogen attach itself here. We're going to have 1 hydrogen attach itself here, and 1 hydrogen attach itself here. Remember what we said, that hydrogen has valence electron of 1, so it's going to bring its own to share. This one is going to bring its own to share. This is going to bring its own to share. You understand? So now if you observe, hydrogen has complete duplet structure 2 in the first shell. Same thing here, same thing here. Nitrogen has 1, 2, 3, 4, 5, 6, 7, 8. So this is a stable atom. That's why we have ammonia. Do you understand? So this is just basically about the covalent bond. So let's talk about some of the properties of covalent bonding. Some of the properties of covalent compounds. So the first property is that they exist as discrete particles or big giant molecules. Example, we have diamond, we have crystals, we have protein. So they can exist in as discrete particles. When we talk about discrete particles, we mean that they are like bundles of atoms which are not joined together, which are not joined to other atoms in a network. When I mean discrete particles, I mean bundles of atoms that are not joined to other atoms in a network. Understand? They can also exist as big giant molecules like likes of diamond, crystals, and proteins. You understand? Now we'll go to the next characteristic. Second, we have they are usually gases. Usually gases or liquid or low melting point solids. Usually gases or liquid or low melting point solids held together by van der Waals forces at room temperature. So at room temperature, they are usually what? Gases or liquids. Or if they must be solid, they must be low melting point solids held together by van der Waals force. Van der Waals forces. You understand? We're going to talk about that probably in the next video. The third characteristic is they do not conduct electricity in solution form, just like we said for ionic, and like the opposite. If you like, put them in solution form, they will not conduct electricity. Understand? They are something called non-electrolytes. They are non-electrolytes. They don't conduct electricity in their molten form. Or in general, say they are poor conductors of electricity. Now, the fourth property or characteristic is that they are soluble in polar solvents. No, sorry, in non-polar solvents. They are soluble in non-polar solvents. And the fifth is they are insoluble in polar solvents. I give you an example of polar solvents. We're going to talk about that in the next video. Now, that is basically just the properties of the covalent compounds. But there's a type of covalent bonding, a special kind. It's called the dative bond, or the coordinate covalent bond. So this is a special kind of covalent bond. Now the reason why it's special is because now initially, for when we talk about just a normal covalent bond, the shared electrons are donated equally, just like in the case of if you observe the shared electron, just like in this case, is donated equally. Hydrogen donated one, this hydrogen donated this one donated this one, so it's shared equally. Same thing goes for chlorine and so on and so forth. But in this case, for dative or coordinate covalent bond, it's just going to be one electron that will donate everything that will be shared. Understand? Let's take an example. Let's take a very good example of this. Let's work with ions. Let's say we have ammonium ion. Let's say we have a bond between ammonia and an ion of hydrogen. Now we drew the structure of ammonia. We have N as the central element, two lone pairs. We have X dots. This X is from hydrogen, dot is from ammonia. We have another one here. We have one more here. Remember when we drew this? We said ammonia, this is the structure. Now when you bond with, now what does this mean? This means that this hydrogen has lost its electron. Hydrogen has just one. It now lose that one that it has. So it has nothing. Understand? It has nothing. So what's going to happen is that this nitrogen, since it has two extra that is not using, it's going to donate it to this guy for sharing. So you're going to have nitrogen here. Same thing. X dot hydrogen dot X hydrogen dot X hydrogen. Please mind you, these are electrons, you understand? Now, since this guy doesn't have anything, nitrogen is going to provide it too for sharing. So hydrogen is just going to come and share with them. Now don't forget the positive sign. Now the positive sign is going to now belong to the whole element, you understand? So that's why we're going to have NH4 or plus. So this is a very good example of the coordinate covalent, where this lone pair meaning it's not taking part in any bonding or stuff. So this lone pair is going to be brought, ammonia is going to donate this lone pair to hydrogen for sharing. So they're going to share it here, understand? Hydrogen did not bring anything because it doesn't have. So everything that was shared was brought by nitrogen. So this is just a very good example of the coordinate covalent bonding. Now let's talk about some of the characteristics of the coordinate covalent bonds, or coordinate covalent the dative compounds. Let's put it that way. So some of the characteristics. So the first characteristic is that they are non-electrolytes, just like the other ones. They are non-electrolytes. By non-electrolytes, first of all, an electrolyte is a substance that breaks into ions when dissolved in water. Just like we said for sodium chloride, when you dissolve sodium chloride inside water, it breaks into ions. So it is an electrolyte, you understand? So for this, we are saying that dative compounds are not electrolytes. They don't break into ions when dissolved in water. And this leads to them not being able to conduct electricity. So they do not conduct electricity. They don't conduct electricity. Thirdly, they are slightly soluble in water. Slightly soluble in water. Fourthly, they can be crystalline or amorphous. Crystalline or amorphous. Fifth, their melting and boiling point is lower than those of the ionic compounds. Their melting point and boiling points are lower or is lower than that of ionic compounds. So these are like the few characteristics of the dative compounds. Now, what we're going to do now is, remember we've talked about the ionic bond, the covalent bond. Now we'll talk about the metallic bond. Now from the name metallic bond, what should come to your mind is metals. So this is just the type of bonds that holds metals together in a crystal. It's the type of bond that holds metals together in a crystal. Now, this is just basically what you need to know. Now we go to the characteristics of metals. Obviously, it's not just the metals. The bonding involves metals, so there's no need to say characteristics of metallic compounds. Just say characteristics of metals. The characteristics of metals. We have first characteristics is malleability. They are malleable. They are malleable. Doesn't mean they can be hammered. And the second characteristics is that they are good conductors of electricity. So they conduct electricity. The third characteristic is they have high melting and boiling points. High melting point and high boiling point. The fourth characteristics is that they are ductile. Fourth, they are ductile. They are ductile. Now, they are ductile and fusible. Now, ductility is the ability of a metal to be drawn out into wires. Just like if you look at your cables at home, it's made up of, most of them are made up of copper wires. So copper is ductile because you can draw it into thin wires. And fusible is just the ability of a metal to be melted and fused together. Understand? Just like people that weld. So you can melt and fuse them together, or the smiths, maybe the blacksmiths, and so on and so forth. Now we go to the fifth characteristic. They are good conductors of heat. They conduct heat properly or very well. Conduct heat. Conductive. Okay, UCT. Conceit, not high density, and they are lustrous. Lustrous. This is very shiny, you understand? So these are the characteristics of metal. So in the next video, we're going to talk about the intermolecular bonding.